Today I will start the properties of conjugate. We take two complex numbers Z1 and Z2. Then first one is Z1 plus Z2 whole bar is equal to Z1 bar plus Z2 bar. Suppose we take Z1 is equal to x1 plus iy1 and Z2 is equal to x2 plus iy2. Then Z1 plus Z2 can be written as x1 plus x2 plus I times of y1 plus y2. So Z1 plus Z2 bar can be written as x1 plus x2 minus I times of y1 plus y2. This can be written as x1 minus I y1 plus x2 minus I y2. x1 minus I y1 can be written as z1 bar and x2 minus I y2 can be written as z2 bar. So z1 plus z2 whole bar is equal to z1 bar plus z2 bar. Now we come to the second property, that is z1 into z2 whole bar is equal to z1 bar into z2 bar. Now the two complex number z1 and z2 are taken and they are multiplied together. That is z1 is equal to x1 plus I y1 and z2 is equal to x2 plus I y2. And if we multiply z1 and z2 you will get x1 plus I y1 into x2 plus I y2. By multiplying x1 plus I y1 and x2 plus I y2 you will get x1 x2 plus I square y1 y2. I square becomes minus 1, so minus y1 y2 plus I times of x1 y2 plus x2 y1. This is the left hand side of the property. Now we come to the right hand side of the property, that is z1 bar into z2 bar. z1 bar is equal to x1 minus I y1 and z2 bar is equal to x2 minus I y2. If we multiply x1 minus I y1 into x2 minus I y2, you will get x1 x2 minus y1 y2 minus x1 y2 into I minus x2 y1 into I. You will get x1 x2 minus y1 y2 minus I times of x1 y2 plus x2 y1. So LHS is equal to RHS. So the property is proved. Similarly, we can come to the third property, that is Z1 by Z2 whole bar. This will become Z1 bar by Z2 bar. You take Z1 x1 plus I y1 and Z2 x2 plus I y2 and you can prove this property in the similar way as you did in the last two properties. And fourth one is Z1 minus Z2 whole bar is equal to Z1 bar minus Z2 bar.